What's the relationship between electric current and electric charge? Find out right now. Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering at your service. Okay, the problem is given as the current is 1000 sine T, and that is given in amperes. Of course, current is in amperes, and we have a definition. And now it's asking, the question wants to know, describe the formula for Q with respect to T. What is that? How do you write an expression given this right here? So this expression, we know that I is equal to dQ dt. Of course, what does that mean? That means that we have, perhaps you can describe it as maybe a surface, a bunch of charges moving through a tube through this surface right here, and all these are the all these are the charges Q, and of course they pass through in a time T. So this is the number of charges that pass from, say, T0 to T1, right? And that is delta T, which is also described as dt. And of course, that's the number of charges is going to be, translates to dq. So we solve this, right? I dt is equal to dq. Integrate both sides. We have q. We'll switch this over here. That over here is equal to the integral of I dt. Okay? So I is described by this over here. So we write Q is equal to the integral of 1000 sine T in amperes. Right? The 1000 can come out. The integral of sine is minus the cosine. This comes out to Q equals to minus 1000 cosine T. And that is going to be not in amperes, but in coulombs. Okay, let's fill in some of the empty spaces on this particular video. The units of current is amperes, and the units of charge is coulombs, and of course amperes are current in terms of coulombs per second. So when you get 1 coulomb per second, what you have is 1 ampere. A coulomb is a pretty large number. It's measured in, coulomb is charge, and it's basically, you can almost count the electrons, and the number of electrons moving past the surface, that is the total of your charge. That's the definition of current. It's stuff moving by. You talk like water, right? Think of current in terms of water. Water moving through a river. That's called the current. And it's the same thing with electrons, except it's not measuring electrons moving through the wire. It's measuring the amount of charge that's moving in through a wire. Now, it turns out electrons are charged particles, and so they carry charge with them. But also you can have holes moving through a river. So it's electrons and holes move in opposite directions. We're going to clarify one thing, that current flow is from positive to negative. That is the definition that electrical engineers and electronics have used for probably at least the last 50 years. And that was, more than that. 75 years at least. And there was some debate about that many years ago, that you can blame Ben Franklin for having electrons go from negative to positive. So current flow is defined as positive to negative, and electron flow, electrons are negative, they go from negative to positive. So current flow and actual particle flow are two different directions. We're talking about current flow, we're talking about holes. And you should know what holes are. Well, holes are missing electrons, which leaves positive charge. Okay? Thanks for watching my program. If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.